At Ciba-Geigy, research scientists create products which enrich the quality of our lives. Products to increase our food supply, dyes and pigments which surround us with color, pharmaceuticals to improve our health, products which reaffirm the value of science to mankind. As part of its continuing program in support of science education, Ciba-Geigy is pleased to present this issue of the Science Screen Report. The Science Screen Report, bringing you each month the latest discoveries, developments, and applications of science, engineering, and medicine, made to help solve the problems of modern life. You are looking at plumes of vapor produced by the natural heat of the Earth acting on underground fluids, one result of geothermal energy. Today, the geysers geothermal field near San Francisco already yields the equivalent of half that city's electricity. Elsewhere in North America, researchers seeking new and better ways to use this power from the Earth. In California's Imperial Valley, the Lawrence Livermore Laboratory has begun a major study of the environmental effects of geothermal power plants. And in Yellowstone National Park, the range of processes due to geothermal forces may be observed in all their natural splendor. The eruption of a volcano is one of the most awesome spectacles on Earth. It is also evidence that our planet is geologically alive, with an extremely hot interior. Other notable geothermal phenomena include hot springs and geysers. Geothermal resource areas exist in many parts of the world and are increasingly being tapped as natural energy sources. In the United States, the geysers field near San Francisco generates about 3 megawatts of electricity, half the power used by the city. The steam from below drives turbo generators. In geothermal power plants, the hot fluids from underground drive generators to make electrical power. No coal, oil, or other fuel is needed. The fluid is then returned to the Earth. The basic energy being tapped is derived from natural nuclear reactions far underground, is transferred upwards through liquid rock. Near one Hawaiian volcano, such a deep heat source has been mapped via surveying and drilling, perhaps to be utilized indirectly. A major North American geothermal resource area is located in California's Imperial Valley. Scientists have found that this valley lies on the boundary between the North American and Pacific crustal plates. and the mantle layer here is very close to the surface. The heat flow from the Earth's interior is much greater, and rock faults allow this heat to migrate upwards and to warm underground water. In this area, geothermal resources take the form of hot, salty brine. The region constitutes one of the richest geothermal zones in North America, capable of yielding enough heat energy for 10 cities the size of Montreal. Unfortunately, the corrosiveness of the brines is a major engineering problem, wearing out ordinary piping and castings. One proposed solution is to run the brine through a specially designed generator plant. To evaluate this rich energy potential, several geothermal test facilities have been set up in the valley. The purpose of these units is to collect data to help choose the most cost-effective designs for full-scale power plants. To find ways to assess the environmental impact of such future plants, a research program is being carried out by the Lawrence Livermore Laboratory of the University of California. Some waste gases, such as hydrogen sulfide, are released by nearly all types of geothermal plants. Air quality studies are therefore part of the project. A network of sensitive detector stations across the valley records air quality changes. Conventional sources of air quality variations, crop burning, industrial emissions, and agri-chemical spray planes are also monitored. The once hot geothermal liquid from below is also traced after use to determine its effects on surface water quality. A specially outfitted vehicle provides immediate analysis of water samples at over 70 collection points. Non-electric applications of geothermal heat include drying food, crops and fertilizer, and heating and cooling buildings. Since this region experiences small earthquakes, geologists on the project are keeping a record of earth tremors and ground settling. To aid the geological study, a series of seismometers were deployed to record ground shifts. Their radios signal the Earthquake Research Center at the California Institute of Technology. From this data, the researchers hope to gain a better understanding of how the extraction of geothermal energy may affect Earth processes. The life systems of the valley are also being closely watched for possible changes due to increased use of geothermal energy. At the University of California in Riverside, food crops are exposed to controlled levels and quantities of geothermal exhaust gases. The plants are then re-examined at intervals to determine any significant negative effects. Though geothermal power plants have operated for half a century in Italy and Iceland, health, community development, and other studies are also underway. One of the oldest known geothermal areas in North America, Wyoming's Yellowstone National Park, provides unusual opportunities to observe a full range of geothermal processes. Nearly always concealed from man's eyes, the living forces of nature are here clearly visible. In the thermal basins of Yellowstone, rain and snow seep into the earth. To be returned as the formation's 4 characteristic features: geysers, hot springs, mud pots, and fumaroles. Of all Yellowstone's natural phenomena, the most fascinating are the geysers, majestic plumes of steam blasted upwards by heat acting on water trapped in natural formation. This split-screen image illustrates the heating process. Hot springs, radiating energy and steaming gas bubbles and surface mist, are also created by scalding water from below, as shown in this split-screen view. One special kind of hot spring, a fumarole, resembles a natural kettle, the water venting as low-pressure steam, again illustrated by a split-screen representation. Mud pots are a 4th type of formation, rock containers holding a mixture of water and clay located on top of fumaroles. The experience of Yellowstone National Park can be overwhelming, its vistas much resembling primitive Earth before life was born. For scientists and laymen alike, geothermal activity is one of the most fascinating of natural processes. Today, Canada, the United States, and other nations are increasingly turning to this force to meet their energy needs. Science Screen Report has been presented by Ciba-Geigys Suffern, New York plant, a leading producer of pharmaceuticals, as part of its continuing program in support of science education.